Hello guys, my name is Atina Zahidah. You can call me Atina. And my name is K1232014. I come from Sukoharjo and I'm from mathematics education. In this time, I will present about averages and measure of speed related with differentiation. First, definition. Averages and measure of speed are concepts used to quantify the rate at which an object is moving in the context of different. Speed is related to the concept of the derivative. Average speed refers to the total distance traveled divided by the total time taken. It provides an overall measure of how fast an object is moving over a given interval. For example, if a car travels 100 kilometers in 2 hours, the average speed will be 50 kilometers per hour. On the other hand, the derivative of a function that represents the position of an object with respect to time gives us in the instantaneous velocity or speed of the object at any given time. It represented the rate of change of position with respect to time at specific moment. In other words, it tells us how fast the object is moving at the particular instant. For instance, if we have function that describe the position of a car function of time, taking the derivative of that function with respect to time gives us the velocity function, which tells us the car's speed at any given time. So, in summary, averages and measure of speed provide overall measures of how too fast an object is moving over a given interval, while differentiation allows us to find the instantaneous rate of change or speed at a specific moment in time. Determining speed using derivative. If S equal F t states the equation of motion of an object along a straight line, where is the displacement or direct distance of the object from the starting point at times t. The function f that describes the movement is called the object position function. In the time interval from tc to tc plus h, the change is position if c plus h minus f c, as shown in following figure. The average speed in this time interval is average speed equal displacement f c plus h min f c times h. equal times h. Suppose we want to calculate for a very small interval h to close 0. Then we obtain the instantaneous speed for t equal c. And next instantaneous speed equal v c equal lim h 2o f c plus h minus f c h. This form is one other than the first derivative of the function s equal ft, namely pc, if the limit value exists. It can be concluded that the speed of a function is t equal ft at the current time is vt s square t or vt f square t, and basically the instantaneous speed of an object's motion at the current time times t is f square t. Instantaneous speed can be positive or negative depending on whether the object is moving in a positive direction or a negative direction. If the instantaneous speed is 0, then the object is erased. And next, determine acceleration using derivative. The instantaneous rate of change of speed is called instantaneous acceleration. Suppose an object moves according to the motion function s equal ft with the instantaneous speed. I repeat, with the instantaneous speed at a constant t being v and the acceleration being a. Acceleration a is the first derivative of v with respect to t, or acceleration is the second derivative of s which with respect to t. From this definition of acceleration, we can conclude that if a more than 0, then v increases. If a smaller than 0, then v decreases, and if I equal to 0, then v does not change. We can see the formula is a equal dv over dt over d square s over dt dt square equal v accent equal s accent. From this, we can conclude that if average speed is the formula is v equal delta s for over delta t, and average acceleration is a the equal delta v over delta t, and if moment speed is v of equal d s over dt and movement acceleration is a of equal dv over dt equal d square s over definition is a particle is moving along a straight line with a position function given by st equal st square 2 minus 2t plus 5. Next, where t represents times in second and s represents the position of the particle in meters. We'll find the average velocity of the particle over the time interval t equal 1 second to t equal 4 seconds. The solution is to find the average velocity. We need to calculate the total displacement. Is the difference between the initial position and the final position, and the total time is the difference between the initial times and the final time. Next, total displacement equal s4 minus s1 equal 3 4 square 2 minus 2 4 plus 5 minus 3 1 x square 2 minus 2 1 plus 5 equal 63 equal 63 minus 6 equal 57 meters of second. Therefore, the average velocity of the particle over the time interval t equal 1 second to t equal 4 second is 90 meters per second. Next problem is a car is moving along a straight road and its position and time for t in second is given by the function st. The velocity function vt is the derivative of the position function st, and represent the speed of the car r time t. 1. Position function. The position function is given by st equal 3t square 2 minus 2t plus 5. Find the velocity function vt by taking the derivative of st. And 2. Average velocity. Determine the average velocity of the car over the time interval a, b. Choose any values for a and b where a little than b. And 3. Instantaneous velocity. Find the instantaneous velocity of the car at specific time t equals c. Choose any value for c. And next, for interpretation the result of the average velocity and instant velocity in the context of the car's motion. What do these values represent in terms of speed, and this direction? The answer is first about velocity function. About velocity function, that differential the position function st with represent 2 times t to find vt. We can use formula vt equal ds over dt, that vt equal 60 minus 2, and that's the average velocity. Choose A equal 1 and B equal 3. For the time interval, calculate the average velocity using the formula. Then, average velocity equal SB minus SA over B mean A. Then, instantaneous velocity, choose C equal to. For the specific time, find the instantaneous velocity by evaluating Vt at Tc. Next, interpretation discuss what the average velocity and instantaneous velocity is just about the car's motion during the specific times interval.